Today's topic is finding slope and rate of change. Based on the topic title, you might ask yourself, what is the slope? The slope of a line is just simply the ratio of the vertical change, the rise, to the horizontal change, the run. Basically, it just means what's the difference in how much you're jumping or rising to how far out you're going. All right, what's the ratio between how high you've gone to how far out you've jumped? You might ask yourself, how do you find the rise? Well, to find the rise, you just simply count up vertically from one point to the other. So you notice here we got the y change, y standing for the rise, y being the y direction, which is the vertical direction. All we have to do is count up. So if we look at this example here, they count up from this point to this point, 1, 2. So our rise is 2. And how do you find the run? You just count horizontally across. So if you count horizontally across from this point to that point there, it's 1, 2, 3. So in this example here, your line is rising 1, 2 every time it goes out 1, 2, 3. It rises 1, 2, goes out 1, 2, 3. Rises 1, 2, goes out 1, 2, 3. So the rise for this problem here is 2. All right. It rises 2 every single time it runs 3. So to actually find the slope is just simply rise over run. So you just take the slope, it equals the rise divided by the run. 2 divided by 3. So the slope for this line is 2/3. There is an alternative method where you can look at the rise and the rise over run as the change in the y's over the change in the x's. And you notice they have all these numbers down there. Where'd these numbers come from? Well, the change in the y's. Let's look at our coordinates here. They have the coordinate 4, 3, where the y value is 3. Well, they wrote the y value here, 3. It says a change in the y, so how much are they changing? So they wrote the value 3 right here and said 3 minus the other value of y, which is minus 1. 3 minus minus 1 is 4. So the difference, how much it rose from this point to this point, it rose up 1, 2, 3, 4, and you can see that there. How far did it run? Well, the x changes here. The distance from this point to this point horizontally, well, they took the 4, x value right here, the x value which is 4, you'll see that here, 4, and subtracted the other x value which is negative 2. So they took 4 minus negative 2. We know 4 minus a negative is a positive, so that gave us a positive 6. And you can see that the x change will count over from this point to that point to find your run. 1, 2, 3, 4, 5, 6. And you can see the x change is 6. So our slope is the rise over the run. Well, we rose 4, we ran 6. 4 over 6 is our slope. It can be reduced to 2/3. So this is the alternative method to figuring out what the slope is. Notice 2/3 and 2/3, we got the same slope for each process. I do have this little comment down here that says be sure to start from the same point. Anytime you're finding the slope, you always got to start from the same point to make sure that you get the values correctly. You might ask yourself, is there a formula for slope? There is a formula for slope. It's kind of a tricky formula. A lot of students struggle with it because it's got y2 minus y1 over x2 minus x1. It's a lot of variables with subscripts 2 and 1. Gets kind of confusing, but it's actually a really easy formula to use. So rise over run, subtract the y value, subtract the x values, and that'll give you your slope. You might ask, where did the formula come from? Well, let's look at this example here. We've got one point which they mark as x1, y1. The 1's just meaning that this is the starting point. This is the starting point. So imagine like if you were to walk up this slope here, you started at this point right here, x1, y1. So this is your first, this is how far out you are from the origin to start with, and this is how far up you are from the origin to start with here, x1, y1. But you ended your walk at x2, y2. That's how far out you are in the x. x2 is how far you are out from the origin in the x. y2 is how high you are up from the origin in the y direction. x2, y2. So the formula comes from, well, if you want to know how high you've risen, all you have to do is subtract the two rise values, or the two heights. So if you take y2 minus y1, that'll tell you how high you've gone. If you take x2 minus x1, x2 being how far you are in this distance, if you take this x value, x2, and subtract out this x1, x2 minus x1, that'll give you how far out you walked in the horizontal direction. Then you just take those two numbers, the rise, remember the rise over the run, so y2 minus y1, whatever you get for that number, divided by whatever this is, whatever number this is, and that is your slope. How do I use the formula? Well, let's look at it in use. You have this slope, or you have this line, 2 points on the line. You got 1, 2 here, and 4, 3 here. So your rise values are 3 and 2. You're up 3 here and 2 here. So if you take this number 3 and subtract 2, so 3 minus 2, that's going to give you 1. And that's the rise. So you're rising up 1. You can look at that pretty easily and see, oh, I went up 1. Now you're going to look at the run. They take 4 minus 1. Take this run value, how far out you are from the origin. So 4 minus the 1 that this one is from the origin. 4 minus 1 is 3. That means you ran 3. So you went horizontally 3. Well, let's check. Did we do that? 1, 2, 3. Yes, we did. So the slope of this is rise over run, which is 1 over 3. So our slope is 1/3. So all you have to do this formula is step 1. Take the value of y2 and subtract y1 from it. Step 2. Value of x2, subtract x1 from it. And then put them over each other. Rise over run. You can also do this backwards. Okay? The formula works the opposite way as well. So instead of doing y2 minus y1, you can actually do y1 minus y2 over x1 minus x2. You can use this formula, and it works the exact same way. Give you the exact same answer. Let's check it out. So in this case here, we got y1. y1 was 2. So we're going to take 2 minus y2, which was 3, all over x1, which was 1, minus x2, which was 4. 2 minus 3 is -1. 1 minus 4 is -3. And you might say, well, that's not the same. It is, because you have a negative divided by a negative. We know negative divided by a negative is a positive. So like I said in the last slide, as long as you start from the same point and get all your calculations from the same point, if you start at this point, get all your calculations from this point, or do the same thing, start with this point and get all the calculations from this point, you're going to get the same answer. It doesn't matter how you use the equation as long as you use it the same way. Now let's find the slope of this line. Again, we need to find 2 points that are sitting perfect on this line. The first point I see that's sitting just perfect is, well, I got this one here is perfect, and this one here is perfect. Let's write the coordinates. This coordinate here is -1, 1, 2, 3, 4, 5, -1, 5. This coordinate here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma, 1, 2, downwards, which is -2. We got 10, comma, -2. So what you could do if you wanted to actually just figure the slope out without using the formula. You don't even have to use the formula. If you want to figure this out just really quick to check yourself, what you can do is just count. So I'm going to count down. 1, 2, 3, 4, 5, 6, 7. I counted down 7, so my rise is -7. My run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My run is 11. So my slope should be rise over run, which is -7 over 11. This is what my slope should be. So now we're going to actually use the formula to check it. y2 minus y1 over x2 minus x1. Well, we got to pick a spot, pick a point to start with. We can pick either of these, this one or this one to start at. I'm going to pick this one just because I'm going to walk downwards. So this means that's x1 and this is y1. And that means this is x2, that's my destination, y2. Just imagine yourself walking down from that point to that point. Well, now you just plug it in that equation. If we do that, y2 is -2. y1 is 5. x2 is 10. x1 is -1. -2 minus 5 is -7. Oh, that was what our rise was. -7. And 10 minus -1. 2 negatives make a positive. 10 plus 1, 11. -7 over 11. Same as what we got for our slope over there. Now we have a problem where we don't have a graph, so we have no way of just counting on the graph up however many we go and over however many we go. We actually just have to go off the numbers. Whenever you have to just go off the numbers, you just use the formula, which is y2 minus y1 over x2 minus x1. And then you just pick. You got a point here and a point here. Both these points are on the line. The line's passing through 5, 2, and it's passing through 4, -1. So all you have to do is pick one. Which one do you want to start with? This one or this one? I typically always just pick the first one. So this is x1, this is y1, this is x2, this is y2. Now you just plug in the formula. y2, which is right here, is -1, minus y1, which is right here, which is 2, over x2, which is here, 4, minus x1, which is 5. -2, or -1 minus 2 is -3. 4 minus 5 is -1. Now you might think you're done, but you're not, because you got negative and a negative. Negative divided by negative, 2 negatives make a positive. So our slope is 3. Again, we're going to find the slope of a line that passes through the points. We got the 2 points here, 0, 4 and -3, 4. Let's use the formula again. y2 minus y1 over x2 minus x1. Again, pick a point, doesn't matter which one. I just usually go with the first one, x1, y1, x2, y2. Plug them in. y2 is 4, so it's 4 minus y1, which is also 4. 4 minus 4. Over x2, which is -3, and x1, which is 0, minus 0. 4 minus 4 is 0. -3 minus 0, -3. Don't stop there. It's 0 divided by negative 3. Anytime 0 is in the mix when you're dividing and multiplying, that means the whole thing is 0. That means your slope for this line is 0. You might ask yourself, when is the slope going to be 0? Well, the only time slope is 0 means, well, slope being 0 means your rise over run, so you're rising. Remember, this is rise, and this is run. What's the only time that you don't rise? When's the only time that you don't rise when you're walking? Well, you don't rise when you're walking on a perfectly flat surface. So a horizontal line is when you have a slope of 0. Now we're going to find the slope of a line that passes through these 2 points, 5, 2 and 5, negative 2. Nothing changes. We got y2 minus y1 over x2 minus x1. Again, pick one of the 2 points. Just for fun, I'm going to pick this one now. Instead of this one, I'm going to choose this one to be the first one I start with. So x1, y1, x2, y2. This just proves it doesn't make any difference. Follow the formula. y2 goes first. y2 in this situation is 2 minus y1, which is negative 2, over x2, which is 5, minus x1, which is 5 as well. 2 minus negative 2. Negatives make a positive. 2 negatives make a positive. So 2 plus 2 is 4. Over 5 minus 5, which is 0. Don't stop here. 4 divided by 0. I've never known a situation where you can divide by 0. You can't divide by 0. That's something that we call as undefined. It's an undefined slope. But let's look at it more in depth. So who cares if it's undefined? What does it mean? Well, it means if we got rise, remember it's rise over run. So we're rising 4, running 0. When's the only time that you're either rising, when you're either rising or falling a number and you don't run at all? It means you're not going horizontal at all. What's the only time that happens? You're either dropping from the sky or you're climbing straight up a rope. So, when you have a slope that's undefined, that means you have a vertical line. Vertical line. That's the only time you have a slope that's undefined is when you have a vertical line.